Next question. MCQ with one or more than one correct answer. C6H5CH2, CH3 taken twice on monochlorination. And this chlorination is with chlorine in the presence of light. An example of free radical reaction. Which of the following statements are correct? So we need to check out of A, B, C, D how many are correct. The major product formed will exhibit optical activity. First of all, what is the product formed during this reaction? For which purpose? Here is the phenyl group CH2, CH, CH3, CH3. And it's a chlorination in the presence of light, an example of free radical reaction. And here is the primary carbon. This is the primary carbon, but this particular carbon, if you can see, it is the tertiary carbon, and this is benzylic carbon. And since it's a free radical reaction, you need to check which carbon free radical that is most stable will be formed, and chlorination takes place at that point. And if the free radical is formed here at this position, it is benzylic free radical, which is more stable than a tertiary carbon free radical. So therefore chlorination occurs at this point with the resulting intermediate free radical as this with CH, CH3, CH3. And this is attacked by chlorine to give the product of the reaction as. Now let us see what are the options given. The major product formed will exhibit optical activity. To exhibit optical activity, there should be asymmetric carbon. So now let us take this particular carbon where you have one is phenyl group, one is the chlorine atom, one is the hydrogen atom, and one is this isopropyl group. So four different groups are there on this carbon. Therefore it is asymmetric carbon, hence exhibits optical activity. Therefore option A is right. The major product formed will exhibit optical activity is right, because the product formed, which is considered to be the major product, is having an asymmetric center, because of which this compound possesses the property of rotating the plane of plane polarized light. What is the B option given? The intermediate free radical of the major product is resonance stabilized. That is the reason this carbon with unpaired electron, which is the free radical carbon, is in conjugation with the pi electron cloud of the benzene ring. And because of that resonance, this carbon free radical formed is more stable than the tertiary carbon. Hence, the intermediate free radical formed of the major product is resonance stabilized is right. C option is the intermediate free radical of the major product is secondary. That is, the carbon where unpaired electron is present is secondary or not. So this particular carbon, if we take, this is attached to this carbon directly and this carbon of the phenyl group directly. So it is a secondary carbon only. So free radical carbon is secondary. Therefore C is also right. The intermediate free radical is planar and stabilized only by hyperconjugation. Just now we have checked that the free radical electron on benzylic carbon is in conjugation with the pi electron cloud of the phenyl group. There is a resonance. So it is stabilized not only by hyperconjugation but by resonance. Therefore here it is mentioned only by. So therefore D option is wrong. So thus A, B, C are the answers for the question. Then what about the planarity? Remove that planarity. From what about planarity? You remove.